好了，随时开始。
我那个 table of content 我那天不讲，就是我第一下你敲两下就行。
不是我敲呢，你看得到我
我敲他妈3下。
你就这样。
这谁在睡啊？
我在这儿啊。
对啊，
对，2下就是1页，好吧？
2下是1页。
对，因为1下我怕看不见。
OK。
我一个也看见了。
对，你就敲2，你就
我一下好像要翻3页，因为我 table of content 不讲。
然后呢？
那你到通过了翻3页也好了，你就
对，你下给我翻3页算了。
哦 ，OK，没事，那你开始了，我自动慢慢翻嘛。
可以，
对吧？
前面也没多少。我随时开始了。
随时开始。
OK，我这个是。Good morning, everyone. We are Group 11. I'm Austin, and here are my teammates, Jumbo and Joy. Today, we are going to present our Capstone project, large language model in financial credit. 干嘛？
我操！你干嘛呀？你干嘛呀？
我刚才不是两秒很想笑，不看了，我把他那个视频关了。
你看到想要干嘛？
要不要？
Good morning, everyone. We are Group 11. I'm Austin, and here are my teammates, Jumbo and Joy. Today, we are going to present our Capstone project, large language model in financial credit marketing strategy. Imagine you are the owner of a growing tech startup. Your company is growing, but cash flow is tight. You apply for many credit loans, but every loan offer you get requires collateral you don't have and a couple of months of paperwork. However, what you need is working capital to cover next month's payroll. Frustrating, right? You ask why they cannot understand what I really need. Now let's switch our roles. Imagine you are a marketer at WeBank. Your day begins with 50 loans applications. Your team spends hours digging into financial reports, trying to guess which companies need credit. But 40% of your recommendations miss the mark. Clients call angrily, "Why show me this? I don't need it." This is a common problem happening every day. Here's the reality. 50 hours a week are wasted manually matching SMEs to products. 30% error rate for guesswork leads to poor recommendations. 12% of conversion loss as frustrated clients turn to competitors. Our project bridges this gap by merging machine learning with large language models to revolutionize credit marketing for SMEs. Let's see how we solve this problem. By noon, your analysts are drawing. You manually cross-check debt ratios, industry trends, and collateral requirements. You may need to spend 12 hours per day analyzing complex financial data, but what if a model can handle all of this for you? Here's our machine learning methods. Our models analyze financial data, such as debt ratios, cash flow patterns, even seasonal trends, to predict which SMEs truly need loans. No more guessing, no more spreadsheets, just data-driven insights in seconds. However, even with machine learning, your team still struggles. You know company X maybe needs a loan, but which product, short-term, green energy, inventory, financing? Your analysts spend days filtering through over 200 credit products for different companies. You probably need to hire someone to do this job, but it's time-consuming and expensive to train him or her. But what if an AI teammate can do this for you? So let's now meet our new teammate, a locally deployed AI agent. Enter a company name and it recommends a perfect product and explain why, like a trained analyst, but faster and cheaper. This is the basic logic how we handle the corresponding issue. We will elaborate more later in the methodology part. So before moving to our project, let me introduce our business partner, WeBank. As China's first digital bank, WeBank focuses on delivering accessible, efficient financial services to individuals and SMEs. With over 400 million individual users and 4.5 million SME clients, WeBank offers fully online, data-driven products such as microloan, micro-enterprise loan, and micro-car loan. The global banking industry is undergoing a digital revolution. Customers now expect instant, personalized services. In Asia alone, digital banks make up 42% of the market. That's a strong push toward innovation and personalization. Despite tech advantages, large language models remain underutilized in understanding corporate credit needs. While traditional machine learning methods focus on credit scoring and automation, large language model can offer deeper insight into customer behavior, enabling smarter, more relevant product recommendation. Our product focuses on how large language model can optimize marketing strategies for financial credit products. The aim of our project is to explore how large language model can be applied to enhance our credit marketing strategies by better understanding the credit needs and risk preferences of SMEs. The first objective is to develop a solid understanding of how large language model function with the context of financial credit marketing. Next, the project will focus on using insights generated by LLMs to optimize the way credit products are recommended and promoted to target SME clients. Finally, the project will establish a set of evaluation metrics to assess how effectively our large language models improve marketing outcomes compared to traditional methods. So to address these objectives in our literature review, we reviewed both traditional machine learning techniques and current digital banking practice. As for the machine learning side, here are the three most popular techniques. Logistic regression is popular for its interpretivity, but it heavily relies on the linear assumption. XGBoost is widely used for its high predictive accuracy, especially in credit risk tasks. Random forest offers strong performance with complex data structures and reduced overfitting. So let's take a closer look at applications of the top 3 digital banks in China. WeBank applies models like logistic regression and XGBoost, but mostly on structured data, which limits understanding of the qualitative factors. FW Bank builds sector-specific machine learning models, but still struggles to extract insights from qualitative or behavioral inputs. My bank uses AI for risk control, but mainly focuses on numerical and structured data. In summary, while machine learning is part of adopted in digital banking, current practice still remains dependent on several assumptions or structured data. It leaves a significant gap in enhancing current machine learning methods and merging with LLM. And as you can see in the table, none of them apply the LLM in their credit marketing. Based on the literature review, current approaches largely overlook the potential of large language models to analyze behavioral data and deliver tailored insights. Additionally, the current and existing credit marketing strategies often fail to distinguish between companies with varying levels of external financing capabilities. The literature review shows a clear gap. Machine learning is widely used but struggles with unstructured data, while LLMs offer new potential to better understand behavior and improve targeting. And next, let me pass my time to my teammate Joy.
Okay, so guys, here I'm gonna introduce the methodology for our Capstone project. So here's the overview. There are mainly 5 parts. The first one is data acquisition, and second one is data cleaning and pre-processing. And these 2 parts are mainly focus will be how would the data be useful and accurate in our further studies. And then we are moving on to company credit need prediction. And this is pretty crucial, and we are mainly using the machine learning models. A company's credit needs is something that came from all of the status. And moving on to the first one, credit marketing through large language model. And then we are moving on to the next stage, which is the large language model part. And we are trying to develop an AI agent with all the takeaways we have learned and we acquired from the past machine learning comparisons, and all of the results that we have, all the structured data, and we are all adding up all the stuff and generate a large language model AI agent. And finally, we also did some evaluation and validation on our whole project. Okay, so the first part, data acquisition. So there are mainly two parts of the data. The first part is company's financial credit data. Uh, we make several assumptions, and we finally decided to use the data drawn from the one database for stock market listed firms. And for the market value, we are mainly focused on 20 billion down to 20 million market RMB, and those we are so-called SMEs, listed companies. So we are mainly focused how they operate and how they survive in the stock markets. And so we are set. So that's the reason we set them as the targeted company. And the second part is the credit product description. Among all of the credit products, they're all looking like pretty similar. Some are some of them have duration differences, and they have benchmark differences. So there's hundreds of thousands of credit product types of credit products, names of the credit products. So in this case, we made several assumptions that we only drawn from China Bank of Communication Bank Construction Bank of China's, and that is offering certain different types of credit products as the data pool, and make assumption that all companies will be choose either all from these type of datas. And here we comes for the data cleaning and acquisition, and all these are all the procedures from data standardization to missing value imputation. And yeah, we all use some type of model that we have learned at school. For example, we KNN imputer or standard scalar, this min-max scalar, and because we are all the datas are all acquired from the database, so it's quite clean and structured. So we just made several mapping to that, and also text cleaning is pretty important, because some of the data are the names of the companies are not that accurate, and also how the categories, these are the text cleaning part. And after all of this, we are doing a correlation analysis based on what we drawn from the wine database. That is our very first step. And what we can have is like drawing some of the conclusion from some of the key financial factors, and compare them with those kind of like the credit needs, and see how the changes are gonna make an influence on a certain company's credit needs, and what's the correlation. And finally, we are having the retrieval augmented generalization optimization, and these we believe that this part is pretty important in our future LLM agent development, since we are kind of like generating or utilizing all the data in these type of CSV data into the text data that is more efficient and more highly percentage used by the AI agent. So we believe that this part is very, very crucial in the future. And yeah, and indeed we did develop much more put much effort in this area as well. So I will be explaining this in a couple of minutes. Yeah, so for the first part, the company credit need prediction, and as mentioned before, we are kind of like adopting three types of different model methods. First is logistic regression, and the second is XGBoost, and third one is the random forest. And kind of like a conceptual insights came from this the comparison between the three models is like we are kind of like obtaining kind of like clean and structured data. So at the very first beginning of our trial, we believe that random forest or XGBoost will have a better performances. And yeah, indeed, after all the trials, we obtained the data. The XGBoost has the best performances, and we are also have those kind of like datas, MAEs, MSE. So yeah, the performances of random forest is good. And also, here comes the credit marketing through large language model. And first step is to further give a further understanding of company's credit need through financial statement. So yeah, make sure we are all of the data or information comes from the company's financial statements. So most of them are statistical data. So we are kind of like making kind of some of the assumptions, that is we are kind of like drawing a conclusion that whether the companies need the credit products or not really depends on, or did have a really high correlation with the company's financial statements. That is our original assumption. And the second part is the recommendation for credit products in the credit pro that we obtain from the internet. So finally is our evaluation and validation part. All of the stuff is listed here. I will be explaining this in a couple of minutes. And here's the result part to show you guys what we have done. And first is data processing and knowledge base optimization. And we believe that building a knowledge base, accurate knowledge base for AI agent is pretty crucial. And we have done several kind of like process in maximizing, optimizing kind of the knowledge base. So what we have done mostly is first is machine learning from the previous part and draw some of the conclusions on the predicting the company's credit needs. And the second part is generating the text data from CSV, and that we so-called RAG optimization for large language model agent knowledge base. And we believe these type of text data will be pretty important. And indeed, after experiments, this it improved like 50% of the or even more accuracy of the agent outputs. Yeah, so here is some of the works that we have done at the very beginning. So we have the kind of like makes a correlation analysis, and here are some of the charts and all the like kind of like key findings, some of the skewness, some of the kind of takeaways that we have drawn from the data's correlation analysis, and give us a little bit more understanding of how the data goes and how we are and whether we are on the right track. So here's some of the insights. I will be explaining this later if you are interested in a Q&A session. And yeah, these are kind of like the also kind of like as you can see, is like correlation analysis. And yeah, I will skip this. Yeah, and these are pretty crucial. These are the predictive performances for all the machine learning methods. And as you can see, the random forest gets the smallest MSE, MAE, MAP, this kind of stuff. So yeah, indeed, random forest is the best among all the three approaches. So yeah, these are our major contributions. Our major achievements is the AI model that so all start from the prompt. Then you are giving them specific name of the company, and then he's like giving 3 steps. The first step is give some of the key financial statements, key financial factors about this company, and the second is like defining whether this company is really need the credits or not. So it's like a second part is like a yes or no question. And third part is if the company really needs the credit products, then he will draw directly from the credit product pool for drawing one credit products exactly from the pool, and then gives the recommendation and gives some of the reasons. So this is the basic AI agent that we have now. And yeah, leveraging large language model for contextual insights. So yeah, for model selection, we are adopting kind of a DeepSeek V32B. It's a pretty large model, especially it's localized. And yes, indeed, we maximize our computation power, but indeed we believe it will be better if we have a kind of like better computing power. And all of the other stuff, structure, prompt engineering for coherent reasoning and output stabilization and system integration, all the stuff. And yeah, for validation, we have three parts. The first part is structured output control and format compliance. And indeed, it's really a hard issue to make sure that the AI really gives it the same types of output, the format or the content is consistent. And we did a lot of work on that. And also for the validation, we have market data inquiry and temporal alignment and human AI cooperated optimization basically it's just about how we are gonna estimate the content that is generated from AI by human. So that's what we so call human AI cooperative optimization. Yeah. And result summary that we believe that we certainly achieved the three objective, and by using all of these methods that I have introduced previously. And here I will introduce Jumbo to give a further discussion on our topic.
Yeah, thank you, Joey. Next, we will come into the discussion section. We believe that we did a great job in achieving our objectives, but there are still two main points to improve our current methodology. Currently, we rely on the financial data of listed SME companies, but SMEs also exhibit a heterogeneous financial disclosures that is shaped by varying operational skills, sector-specific practices, and localized regulatory environment. This makes the inclusion of this kind of data also necessary. Also, we have identified several computational bottlenecks in processing the data and training the data and training the ML and LLMs. To address these challenges, we propose the usage of a hybrid training pipeline to combining GPU accelerated training pipelines to overcome computational constraints of processing structured SME data at scale. These proposed refinements aim to concise the tension between computational scalability and contextual precision, a fundamental requirement for deploying AI-driven credit solutions in SME ecosystems. Now, let's explore the strategic implications of our framework for WeBank, and three key operational adjustments are essential to align the framework with SME reality. First, SME credit assessments require a shift from conventional financial statements to alternative data integration, such as utility payment histories, social commerce platform ratings, and logistics partner feedback. Implementing federated learning techniques can address data sparsity without compromising compliance. Second, the heterogeneity of SME financing needs demands a dynamic product matching strategy. By correlating LLM extracted industry trends with ML predicted liquidity gaps, the system can automate adjustments to loan terms, such as grace periods aligned with harvest cycles or inventory liquidation timelines. Third, SME borrowers often require transparent rationales for credit decisions. Augmenting the LLM's output with interpretable risk descriptors, such as localized economic stress indices or supplier concentration ratios, which will enhance trust and regulatory compliance. These enhancements will not only align the system more closely with WeBank's SME-focused mission, but also enable the company to sustain competitive differentiation, as it can enhance brand loyalty while LLM can constantly learn and evolve to provide a more accurate credit product recommendation. Next, the integration of LLMs into credit marketing brings three significant shifts in financial analytics. For private sector, by processing real-time social media discourse, regulatory announcements, and industry forums, and heavy feature engineering, LLMs can extract early warning signals about sector-specific risks, enabling proactive credit line adjustment and improve default prediction accuracy. For public sector and government, LLMs can actually facilitate the analysis of policy documents and rulings. allowing government to initiate compliance shifts and launch regulatory evolutions. These innovations represent a significant transformation in the way financial institutions can approach credit analytics. But there are also several critical ethical imperatives that must be addressed. A common concern lies in mitigating systematic biases inherent in financial datasets, particularly given the heterogeneous nature of SME operational environments. Appropriate protection of training data is essential to protect users' data privacy, while training data optimization must prioritize representational equity across regional industries and enterprise scales to prevent algorithmic discrimination. Then we will discuss the limitations and future directions of our project. For our first limitation, while the current framework leverages robust data sets from star-listed companies and authoritative financial databases, future research could broaden applicability by incorporating diverse data sources tailored to small and medium-sized enterprises, adapting pre-processing pipelines for heterogeneous SME data, and expanding access to alternative indicators such as industry forums and regional policy updates could enrich contextual analysis. Next, the study's integration of LLMs demonstrates promising results, yet further refinements could amplify their financial domain expertise. Developing lightweight fine-tuning protocols and integrating domain-specific knowledge graphs could improve interpretability, computational efficiency, and the model's ability to discern material financial signals. Last, the hybrid ML-LM architecture establishes a foundation network, but deeper convergence of analytical approaches could unlock transformative potential. Exploring unified modern architectures where ML algorithms and LM benefit each other through creating feedback loops could refine prediction accuracy and establish a template for next-generation AI systems. After overcoming these limitations, we also believe that the connection of AI agents to real-time data is the most important future direction. We believe that through this connection along with multi-layered architectural structure, LM can output stable real-time recommendations.
To conclude, we have achieved a revolutionary hybrid framework that merges machine learning with large language models. We developed a system entirely from scratch. It's the first system to combine machine-driven predictions with LLM-generated rationale. The output reaches analyst-level precision but operates at machine speed. For WeBank, it unlocks a significant competitive advantage. Instead of offering generic loan products like many competitors, we can now deliver needs-based credit solutions. For instance, when the system detects that SME is likely to need working capital, it can immediately recommend a short-term loan with streamlined procedures. Looking ahead, we plan to validate the system's scalability by deploying the AI agent across over 1,000 SMEs. The next step is integration, giving SMEs the ability to interact directly with the AI agent for self-service recommendation. As we move towards full deployment, we are not just building a product. We are shaping the future of intelligent, ethical finance. That's all for our presentation today. Thanks for your time, and we are open to a Q&A session right now. Thank you.